So, last week we were talking about bus stops, okay? And we were saying how if it's just a divide problem, that's our first bus stop, right? Okay? And then if it was a completely factor problem, that was our second bus stop, right? And then if it was a find the zeros or find the solutions or solve type of problem, that was our third bus stop, our destination, right? Okay? So that's going to come back into play today. We're going to not necessarily stop at bus stop number 1 anymore because bus stop number 1 is just that. Let's go farther. Okay, we're going to go farther. And we're going to go farther in life. Okay. So last week I gave you extra information, right? I gave you that this was a factor, or this was a zero, or this evenly divides into this. You know what I mean? I gave you all of that stuff last week. Today, I'm not giving it to you anymore. Okay? I'm just going to say, here's a polynomial function, completely factor it, or here's a polynomial function, find me the zeros. Okay? And you're going to say, oh, that's so hard. Yeah, but at the same time, it's super easy. Okay? Because we have something out there called the rational zero theorem. Okay? The rational zero theorem says that, okay, if we have a function, f of x equals yada, 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 okay, whatever that function is, then every rational zero of it has the following form. And Q goes on the bottom, and P goes on the top. And actually what I'm going to do with that is I'm going to change that into that color. Because then I'm color coordinated. Yeah. So every rational zero of that function can be written as a fraction where the numerator of that fraction is a factor of the constant term at the very end, and the denominator of that fraction is a factor of the leading coefficient, the very first of that. So, if I'm looking at this function, and I just threw up a random old function, and I don't really even care what the b is, and I don't really even care about this plus or minus signs in between, okay? But 2x squared plus fill-in number here, x, plus 15, okay? Or put a subtraction sign in there, or, put 2 subtraction signs in there for all I care. I don't really care. All I care about is that this number here is my constant term. And so I need to find the factors of 15. Let's take a pause for the cause and let's back up to, I would say about 6th or 7th grade. What does it mean to be a factor of a number? Yeah, go ahead. What does it mean to be a factor of a number? What do you got right? It divides into that number evenly, right? Or there's a number, a whole number that I can multiply and I get that number, right? Okay, so what are the factors of 15? What are the numbers that go evenly into 15? 1, 3, 5, 15. Are there any more? What are they? -3, -5, -1, and -15. So we could really say plus or minus there on all of those, right? Okay. So that's my constant. That's the factors of my constant. Now I look over here and I say the factors of my leading coefficient. What are the factors of 2? What do you got? Plus or minus 1 and plus or minus 2. Okay. From here on out, I will just assume the plus or minus. So you can just give me numbers now, and we'll just all assume plus or minus when we're dealing with factors. Okay. All right. So that means then that now my zeros I take this first number, which is always going to be a 1. Okay? That first green number is always going to be a 1. So I take that and I divide that into all of those. Well, that's just going to give me that list again. Okay? Now I take all of those numbers and I divide them by the next factor in green. So that would be then plus or minus 1/2, plus or minus 3/2, plus or minus 5/2, plus or minus 15/2. Okay. So what we've done is, on a small scale, we've taken an infinite amount of possible zeros, okay, and we've narrowed it down to a field of 16. Because there's 8 numbers, each with a positive and a negative, so there's 16 possible zeros. From that list of 16 now, we're going to find the 2 that make this work. Okay? And then we'll go from there. Okay? All right. So, let's try it on a grander scale. What I would like you to do now is I would like you to list me all the possible rational zeros of this function. So, I'm looking at factors of 8. I get plus or minus 1, 2, 4, and 8. Yes? Then I look at factors of 2. 1 and 2. So my list of possible zeros is plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, right? Plus or minus 1/2, 2/2, right? But what's 2/2? 1. I already got it. I don't need to repeat it. 4/2, that's 2. I already got it. Don't need it again. 8/2, 4. Already got it. Don't need it again. So that's my list then of possible zeros. So we've narrowed that field down even further. We've narrowed that field down to 10 possible zeros, from which how many would we need? At most, we would get 3 out of there, right? But we could also get 1 out of there. Only 1. So we'd have to eliminate at least 7 of those. Okay? All right? So let's go about that process. Let's start that process. Okay? The first thing, I'm going to give you a polynomial function, just like I gave you one last week, but after that, then I said if x plus 3 is a possibility. Okay? All right? Or is a fact. Now I'm not giving you that anymore. So your first step is you've got to narrow your list down. Okay? Right now, it's an infinitely long list. Let's narrow it down so we can start finding some actual zeros. Okay? So I look at this number, 18. What are the factors of 18? 1, 2, 3, 6, 9, 18. Okay. So we've taken our infinitely large list and we've narrowed it down to 12 numbers. Okay? Now, from those 12 numbers, you are going to find a 0. Now, notice how I didn't have to do the green number here, right? Why didn't I have to do the green number? Because the lead coefficient is 1. So the only factor of 1 is 1, right? Okay? Okay? Throw something at him next time. Okay? So, how do we find a 0? Okay? Well, we need to find one somehow. And so what we're going to use is, you are going to use synthetic division to find your 0. Okay? The reason that you use synthetic division is because not only do you want to find your 0, but you also want to find what the factor is if you factor out that 0. Okay? I could plug in these numbers, these red numbers, I could plug into my function, and if they give me out a 0, I could say, well, that's a 0 then, right? But that doesn't help me going forward. Okay? So we're going to use synthetic division the same way that we would do that, and we're going to try and find one. Okay? So let's try to find one here. So let's start with 1. My coefficients are 1, 2, -9, and -18. 1, 1, 3, 3, -6, -6, -24. Don't like it. Okay. So 1's gone. What do you want to try next? 2? Okay, we'll try 2. 1, 2, -9, -18. 1, 2, 4, 8, -1, -2, -20. Okay, -2. You want to go to 3? Let's go to 3. But you could try -2 if you wanted. Ooh, that's a bad, that one kind of rose up. 1, 3, 5, 15, 6, 18. Oh, guess what? It's a 0, right? Okay. So because 3 is a 0, that means that what? 3 is not a factor. X minus 3 is a factor. Okay. Which leads me into, oops, my next one. Like, caramba, now I gotta go all the way back up here to get rid of that shad. Now, I'm going to factor that polynomial. So my new polynomial now is f of x is equal to x minus 3 is a factor. And when I divide x minus 3 into that polynomial, what do I get? I get x squared plus 5x plus 6. Remember, these 3 right here give me my result. That's why we use synthetic division to try that. Okay? Because it not only finds us a 0, but it also gives us the result, the remaining factor. Okay? Now you got to say to yourself, is this factorable? Okay, what does it factor to be? And then x plus 2? Okay. Now, we were talking bus stops earlier, right? This is bus stop number 2. Now we've completely factored it, right? What if this trinomial is not factorable? Quadratic formula, right? Okay. And then this step up here would be bus stop number 2, right? What if you started with an x to the 4th original function? You'd have to find 2 zeros first to get it whittled down. Okay? All right? And so you'd have to get it until you can factor it all the way. Then, now we can go on to step number 4. Now we can solve it. How do I go about solving this problem? Set them all. Oops, you know what I forgot back up here? That's why it looked goofy to me. I forgot an equal sign right there. So I set them all equal to 0. And then I solve them all. So my answers here, my 3 zeros, are -3, -2, and +3. And that, ladies and gentlemen, would be our third bus stop. Okay. Handle? Now, before I turn you loose on this one, you may be asking yourself, why can't I just use grouping on this one? It's got 4 terms, right? Okay? But if I tried to group this, I'd pull out an x squared, and that would leave me with x minus 4. And I'd pull out a -3, and that leaves me with 5x minus 6, right? Can I go any further? No. That's why I can't use grouping on this one. Okay? I can't use the grouping, so I've got to use this new way of doing it. Okay?
How do you know if you can use it?
You look at it, yeah. And if, this way will work even if it is groupable. Okay? So, try this one.
Okay, you can take this one.
All right, so I need factors of 18. What are my factors of 18? 1, 2, 3, 6, 9, and 18. Okay? Did anybody find one that worked? What do you got, Luke?
I have 1.
You have one that worked?
Yeah.
Okay? All right. Nope, hold on. For some reason now it's not working. Come on. Come on, Tron. Why doesn't the green one work? I know, but I don't know why the green doesn't want to work. Alright, we're just going to go that way with it. Okay? So, 1 you said worked, right?
Yeah.
Okay, so that's 1, -4, -15, +18. That's going to be 1, 1, -3, -3, -18, -18, 0 works out, right? So that means that 1 is a 0, right? We can make that be a better 0. If 1 is a 0, then x minus 1 is a factor. Okay? So that means that I can rewrite f of x here now as x minus 1
times x squared minus 3x minus 18.
okay, is x squared minus 3x minus 18 factorable?
Yeah.
Yes. So that becomes f of x equals x minus 1 times x minus 6 and x plus 3. Okay, I like it. So from our list, had we tried +6 or -3, we would have also gotten zeros, correct? Okay, all right. Now, what? Solve it, right? So we get x equals +1, x equals 6, and x equals -3, right? And that's my answers? Why not, Cheyenne? That's what we did. Yeah, we said x minus 1 equals 0, and then x plus 6 equals 0, and x plus 3 equals 0, and so we got positive 1, positive 6, and negative 3. That's what she just said.
What?
That's exactly what she just said.
I wasn't listening.
Well, I'm fully aware you weren't listening.
Is the answer just that right there because we're only stopping at the second bus stop?
Why are we only stopping at the second bus stop?
It tells us to list the rational.
It says find all the factors. It doesn't say find the zeros. It says find the factors. So this right here is my answer. Okay? So, I did that to make a point. What point do I want to make? You've got to read the directions. You've got to. Because it's going to tell you what bus stop I want. Okay? Okay? Now, yeah, you also got to listen too. Okay? Alright? Now, in the directions also, it might say find the real zeros. So if you got an imaginary 0 at the end, you wouldn't give that one because that's not real. Okay? Remember that if this trinomial here is not factorable, what do you have to use? Quadratic formula. Okay? Alright? So know that. Okay? And if you get imaginaries in the quadratic formula, just forget about it. If it says in the directions, find all the real ones. Okay? If it says find all the zeros, then I want both real and imaginary. Okay? With me on that? Fantastic. Okay. This homework will be due on Monday.